By the end of this tutorial, hopefully you'll be able to analyze some data that's given to you, define the following vocab words that we have on up there, and create some marginal distributions, conditional distributions, and relative frequencies. So let's first take a look at individuals, variables, categorical, and quantitative variables. Here is 10 randomly selected U.S. residents from a census. And notice they have a bunch of information like state, family members, etc. The first question that a statistician would like to ask is, who are the individuals in the set? Well, we actually have the answer right here. They tell us 10 randomly selected people from the U.S. Census. And you could check and you could actually make sure 1, 2, 3, and actually go down the line and check to make sure there are 10, but there are. The second thing we'd ask ourselves are what variables are actually being measured. And there's two types of variables here. You're going to get a categorical variables, and categorical variables are usually put into groups and categories. Usually these have like names. So like if you look at the first one of state, notice that state has a good name, so that is categorical. Number of family members, no, those are numbers. Age, no. Gender is male or female. Marital status, that's categorical. And income and travel time to work or not, because you can't put those in categories or groups. So that means that leaves us with a different type, and that is quantitative, which is numerical values where it makes sense to take the average. So quantitative would be like number of family members, age, income, and travel time to work. Because you could all take the averages of those, and those are represented by numbers. The last problem, describe the individual in the first row. So let's just highlight that first row. This person is from Kentucky. They have 2 family members. Age is 61. They are a female. Married. Total income is $21,000. And the travel time to work is about 20 minutes. So let's take a look at a frequency table. A frequency table is pretty self-explanatory. This is a frequency table for radio stations. So all we have is the format or the type of radio station and then the amount of times it happens. So adult contemporary, people listed 1,556 people, listed that as their station they listen to. And this just gives us a total count. To turn a frequency table into a relative frequency table is quite simple. We will want to do that to look at percents. So to do adult temporary, you do 1556 divided by 13,838, and that would give you 11.2%. If you wanted to do adult standards, you'd do 1,196 divided by 13,838, and that will give you 8.6. And you could literally just go along the line and calculate each and every single one. And if we do that, these are the numbers we come up with. A quick little note is look at what my total is. It is close to 100%. Obviously with rounding errors it's a little off, but usually this number is 100%. Alright, that was a one-way table, so here's a two-way table. It's a two-way table because it has two different variables happening. We have gender and chance of getting rich. So if you look at our gender, that's either female or male, and then the opinion would be over here. So a two-way table can be read in many different ways. And the first one is a marginal distribution. A marginal distribution only looks at one thing of the data. So we could take a look at the marginal distribution of males. And if you look at the males, we have a total of 2,459, and our total population is 4,826. And we could go ahead and calculate that number, and I believe it should give us just a tad over 50%, 50.9. So that means females, if we look at the total amount of females, that is 2,367 divided by the total amount, and that's going to give us 49.1%. So that is just marginal distribution for one variable. You could go ahead and calculate the marginal distribution of opinion. And here you have 5 different categories. You got almost no chance, you got some chance, you got 50-50 chance, and you have good chance and almost certain. To go ahead and look at those, what you would do is almost is 194 divided by the total 4,826, and you could go ahead and calculate that, and that will give you 4%. You could go along and then do some chance, and that would be 712 divided by 4826, and notice my bottom number is never changing. You could go ahead and calculate all of that. A quick little note though, marginal distribution tells us nothing about the relationship between the variables. It just focuses on one variable. To actually compare the variables, we will look at conditional distribution. Conditional distribution is where you just put a condition. For example, your parents say you could go to college anywhere you want. The condition comes in as long as it's within a 5-hour drive. So now this is a condition. You could go to college, but it has to be within 5 hours. So if you look at the nice handy dandy map I have here, we're obviously the blue dot. Well, Montana's not a 5-hour drive. Washington, Oregon, California, all these states are starting to be crossed out. So essentially what happens is you have to pick a college within that circle because your parents said within 5 hours. That is conditional distribution. So if we look at conditional distribution of opinion among women, what we are doing is just focusing on this category. We want nothing else but that category right there. So let's almost no chance equals 96 divided by 2,367. Whoop, one extra there. Some chance of women is 426 divided by 2,367. And here I'm calculating the conditional distribution of chances for women. The condition is it's women, so I'm only looking at them. And you could go along the line and figure out the rest of those. You could then also do the conditional distributions of men, and your chart should look something along the lines of this. And that is it for conditional distributions and marginal distributions. Hopefully we have a little more insight.